that actually explains why we talk about probability at this point. And it's because it's an application, it's the main application of counting, right? So what's the probability that we get the event 246? Well, that's actually the number of ways in which I can get one of the states in 246 divided by the number of ways in which something happens, right? So the number of ways in which I can get one of 246 is 3, right? Because that's, well, I get a 2, a 4, or a 6. Those are the 3 different ways, okay? And then the number of ways to get any event is 6. It's 1 or 2 or 3 or 4 or 5 or 6. So the end probability is a half, okay? So counting is really going to be our workforce for doing a lot of this probability, okay? Now you have to be a little careful, okay? Like the numerator and the denominator actually have to count the same things. So they have to agree on repetitions, they have to agree on ordering, okay? I tend to well, you just got to make sure that you're consistent in what you're counting so that you get the right numbers. Now, every once in a while, we're not going to be able to just quite do a division like that, so we might have to break it up, break the fraction into different parts. You may have to decide, oh, you know what? Let's not count the orderings, that's not important, and just reconsider the way you do the count so that it all equally likely. Okay. All right, so let's do some applications of all this. Okay. So let's try to get a pair, okay? So number of ways to get a pair divided by the number of ways to get a poker hand. This is probability of a pair. Okay, so let's deal with this first. Number of ways to get a poker hand, okay? So how can I count that? We're gonna use the techniques we did before. We have 1, 2, 3, 4, 5 different items that we're gonna be selecting, right? So how many ways can I pick the first card? Well, that's 52 ways. How many ways can I pick the second card? 51. The third one is 50, 49, 48, right? And this is counting orderings, right? You know, because if I pick the king of jacks and I pick the ace of spades, I could have done it the other way around. So this is actually counting orderings. If I don't want orderings, then I need to divide by the total number of ways to rearrange those 5 cards. And that is, of course, 5 factorial, right? Because I choose this one 5 ways, 4 ways, 3 ways, 2 ways, 1 way. That's just 5 factorial. By the way, this whole thing is equal to 52, choose 5, right? And that makes sense because I picked 5 cards out of a deck of 52. Okay, so that's the number of ways to get a poker hand, right? Now, what is the number of ways to get a pair? Well, let's see. I want to do the same sort of thing, okay? And how many ways can I pick the first card? Well, 52 ways. Okay. Now, this next card is going to be my pair, right? So how many ways can I pick that card? Only 3 ways, right? Because let's say that I pick the jack of spades, then I have to pick the jack of hearts or the jack of clubs or the jack of diamonds. Those are the only 3 cards that I can pick, right? So that's kind of our count, okay? Now, what about here? I'd like to say that the answer is 50, but it isn't, okay? That's because if I pick the jack of spades and then the jack of hearts, then I cannot pick the jack of diamonds next, right? Because then I wouldn't have a pair, I'll have a triple. So actually, there's only 48 ways to pick that card, okay? And how about this one? 47, right? No, not 47. Because let's say that I pick the 10 of clubs, then I cannot pick the 10 of hearts, right? I need to pick something that's not a jack, not a 10. So actually, there's only 44 cards left, and there's only 40 cards here. Okay, and again, we're doing this. We don't care about ordering, so we're going to have to divide by 5 factorial. Okay, so that's our number, and then we take this divided by that, and that should give us the answer. Okay, so let's see. That's the denominator. Like I said, that's pretty easy. Just 52, choose 5, and then I have the numerator. Oh, I'm sorry, I went that a little too fast. For purposes. I don't want to divide by 5 factorial because that gives me kind of the reorderings of all the cards, but I chose them in a very specific order. So really what I have is the pair, there's 2 ways to have, and the other 3 cards, there's 3 ways to have. So it's not 5 factorial, it's just 2 times 3 factorial. Okay. All right. So yeah, we have now the probability, and so what exactly is this equal to? Now it's just arithmetic, right? So if I figure out the numerator, that's a little bit over 1 million. The denominator is almost 2.6 million. So the answer is, roughly speaking, 42%. So getting a pair is actually pretty common, right? In poker, is 4 out of 10 times you're going to expect to get a pair. That's not bad. Okay, let's look at some other problems. I want 2 pairs, right? But I don't want 3 of a kind, 4 of a kind, or anything like that. I just want 2 pairs. So again, the denominator is the same. So all we need to worry about here is the numerator. Okay, and I'm going to break it up like this. Here's 1 pair, here's the other pair. So I have 52 ways of choosing that one. That leaves me 3. Okay, and for the second pair, I got 48 ways of choosing this one, and now that leaves me 3 there. Okay, then after that, I have 44 ways of choosing the 5th card. Again, I'm avoiding getting 3 of a kind. Okay, and I have to worry about the reorderings. So this could have come in any way, so that's kind of 2 factorial. These could have come in any way, so that's 2 factorial, right? And then, you know what, I could have picked the aces here and then the kings, or the kings and then the aces. So I need to divide by 2 factorial again. This 2 factorial is just ordering those 2 groups. Okay, so let's see. The total number, which, you know, we see here, is only 123,000. So now we're looking at 5%. Okay, so 2 pair, 40%. I'm sorry, 1 pair, 40%. 2 pair, 4%, or almost 5%, I guess. That's quite a drop, right? So that's a lot less likely. Okay. Okay. So we have 2 different poker hands. You know what? We might as well keep applying probability. Let's do 3 of a kind. Okay, but not a full house, not 4 of a kind. So it looks like this. Okay. Well, I have 52 ways of choosing that one. And now when I come over here, there's only 51 left, only 50 left, okay? And I'm going to have to divide by 3 factorial because of the ordering of those, right? And how about the remaining cards? Well, I can't pick the 49th one, right? So I have to pick 48. And then I need to be careful that I don't get a full house. So I need to go down and pick one of the remaining 44. So how many total am I talking about here? Well, there's an ordering there, 2 factorial. Okay, and that's the numerator. The denominator does not change. Okay, and so now we got about 2%, right? So about half as much as doing 2 pair. Okay, all right. By the way, do you notice that the winnings, right? You know, the winning hands are the less likely hands, right? And that totally makes sense, right? Because, you know, you have to get lucky to get one of these. Okay. How about a full house? So now what I want, right, is 3 and 2, but these are 3 of a kind and 2 of the same. So I'm going to have 52 here, 51 and 50, and then of course 48. But then for the next one, it has to be the same type as the 48, the same number. So I only have 3 to choose from, right? And again, I need to divide by 3 factorial and 2 factorial. Notice that I can't get the 2 and the 3 mixed up because there's a different number of them. Okay. All right. So let's work out the numbers. That ends up being 3,700 or 0.14%. Okay. Now you're getting exceedingly rare. And if you have experience playing poker, then yeah, you might agree with some of these numbers. Okay. 4 of a kind. Okay. So again, we're going to have the numerator. I have 52 and then 51, 50, and 49, right? Those are the 4 of a kind. Those are the only 4 cards that can show up. I do not care about ordering, so I need to divide by 4 factorial. Okay. What about the last card? Well, I can pick any one of 48 cards, and I'm good, right? So that should be my number. And again, let's look at the actual result. There's only 624 of those hands. Okay, so the probability now is 0.02%. That's how unlikely 4 of a kind is. Okay. How about a straight? Okay, so a straight means that I get like 3, 4, 5, 6, 7, right? But I don't want a straight flush. Okay, which means they're all of the same kind, or a royal flush, which means that they're actually ace, king, king, queen, and so on. Okay, so let's see. Okay, I'm actually going to do this differently than some of the other ones. I'm using the sum principle here. So the first thing is, so how many ways can I pick the first card? It's actually not 52 anymore. Okay, because this first card is going to be the low card in my straight. So what I need to be careful about is I need to have enough cards left to be able to go all the way to the top. So it's actually only 40 left, okay? And that's because, well, let's see, what's the smallest one that I could possibly pick? 10, so that I can have 10 Jack, Queen, King, Ace. So if I start with 10 and count all the other ones, there's 40 of those that are possible. Okay, now what about the other cards? Well, once I pick that one, then there's only 4 ways to get the next one. Because if I have an 8, then it has to be a 9, and there's 4 of those. And then it has to be a 10, and there's 4 of those. And a Jack, and a Queen. Okay, so so that's what solves that. Okay, so all right. The problem with this is that it might actually count that that extra card, right? Well, it's the straight flush that I'm really concerned about. Okay, so here's how we're gonna take that away. Suppose that I pick one of those 40 cards, and let's say, for example, that I have the 4 of hearts. Okay, that's my pick. Well, then I have to pick the 5 of hearts. There's only one way to do that. And then the 6 of hearts. Okay, again, there's only one way to do that, and so on. So that's why I got one too many ones here. So that's why those 40 times 1 times 1 times 1. That takes care of the straights. Okay. Flushes, right? So this is the actual number, right? I don't have to worry about ordering because there only comes in one specific ordering, right? First I pick the low one, then the next one up, then the next one up. So the way that I counted already took care of that. So this ends up being 0.4%. Okay, that's pretty low. Okay.